actually. All right. And 1, 2, 3. And we're live. Hi, everyone, and welcome to this hors-série community call. It's not the usual one we do, but it's a special one, actually, a really special one. I'm joined today by a bunch of people, which I'm going to present a bit later on, but amongst them, I want to say that we have Tom and Ariel from StarkWare as product team, and we will talk about version 0.11, and we have Gal, who has been the organizer of this call, actually. And we are joined also with a bunch of builders from the space. The goal of this special community call is to present the upcoming version 0.11 of StarkNet to the world so that, we can detail what is in it, what is not in it, how people should prepare for it, and answer any remaining question. The goal also is to basically make sure that everybody understands what 0.11 entails, because it's going to be the first version on which, the first version upgrade of StarkNet on which token holders will get the opportunity to vote. Which is an amazing milestone when you think about it. We've been talking about decentralization for a while. This is one of the first, this is one more concrete step in that direction. So I think, Gal, you will explain the process exactly how this vote will happen. Do you want to explain it now in a few seconds, Gal? How will this vote happen?
I think this question is probably for Manor or Devin or Sylv.
Yes.
All right. So, Sylv, do you want to explain? Manor, are you here?
But he doesn't have a voice.
I'm here, sure, but my voice is
yeah, he's here
good today. So, Sylv, you can go on, and if I will join if.
Yeah, I can quickly just explain a bit about the Builder Council, right?
Yeah, okay. So because you're right, when I say token holder, seems vague. Who will actually vote on this upgrade? We'll have delegates, right? People who submitted their profile as delegate will have the ability to vote with the votes that were delegated to them, as well as the Builders Council. And we have a large number of people from the Builders Council present today.
Yep. So folks, happy to see you all in the first call together. Feel free to ask any question that you have. I know a lot of you have already reviewed the documentation or were in the previous community call. So feel free to shoot if you have any question or anything else. Don't be shy, and get ready for a vote in the coming month.
How do you get ready for voting, Sylv? Like, where will this proposal be published? How will the vote actually happen?
Vote will be held most likely inside a call like this. I set up another safe right now. Currently, I'm just a 1 of 1. I'll probably add a couple more people from the Builder Council just for availability purposes, just to make sure that everything runs smoothly when we actually have to vote. But that's about
what's
as far
safe?
as we
It's
go.
a Gnosis safe, a multi-sig?
Yeah, multi-sig on L1. Currently, there's only my address in there. So we'll just once we do get the proposal for voting out, we'll reconvene again in a call like this. Everyone will have to do a bit of homework, review exactly what's the content of the release. Then we do a single vote like this, yay or nay, and then we just vote on the multi-sig on Snapshot to say yay or nay as the Builder Council.
Fantastic. So, let's start with the homework. Tell us everything, Tom. What is in 0.11?
Okay, thank you very much. So, as you said, to me, it's like actually, I was very excited towards this call because, like everything else we do in general, we also, the governance process is like progressing slowly and in steps, but this is like a real first step, even though it's small, towards not only decentralizing the protocol, but also the decision making and how we do stuff on StarkNet. So yeah, I'm very happy. Having said that, I'm not here to be happy. So let me tell you a bit about what we have in store. So I will share my screen. It's disabled.
Oh, I
The
always need to say, yes, yes, you can go ahead. Yes, yes, you can go ahead now.
Yes, okay, great. So I'm sharing my screen. Can you see it?
Yes, we can.
Okay, great. So I will give a bit of a context to where 0.11 lives, like in the broader roadmap or timeline of StarkNet. And then Ariel go deep into the details. And once we understand where we are, we'll explain how 0.11 try to achieve its purpose. Okay? Sounds good. Okay, so this is basically the context. Today, we are somewhere here. At the beginning of the month, we released like the first usable version of Cairo 1, apologies. And actually today, it was not yet tweeted, but it is out. We have another version of Cairo 1 released. And if you want to be amazed, just go to the release notes and see what has been done in the last 3 weeks. It's really mind-blowing, but the nice thing about the released version today is that you can write, compile, and test the ERC20 contracts. So go check it out. But we are today, and hopefully by the end, it was supposed to be a bit earlier, but as it seems right now, by the end of the month, of next month, we'll have StarkNet Alpha 0.11. Where the goal of this version is basically to add Cairo 1 compatibility into StarkNet. And in the wider context of our roadmap, why we want that? We want that in order to start as soon as possible what we call the transition period. Okay, the transition period is basically the ability of builders and the application developers to start migrating their code from Cairo 0 to Cairo 1. And during this period, to port it, to audit it, and then to actually deploy it. And then after we finish, or the ecosystem as a whole finish with this process, somewhere in the future, we'll have the regenesis. Okay, so this is the context. Now, I want to dive a bit deeper into the roadmap and the priorities, and then go back to it, and hopefully it will give a bit more context. So, okay. Was not supposed to be an animation, but if you remember, I discussed it, I think almost 3 months ago in Lisbon. What are the current priorities for StarkNet as we see them, at least? So the first and foremost is the performance. And actually, the latest version, 0.10.2, added the optimistic parallelization, which gave a good enough improvement to the dire needs of Gerli and mainnet. And even though we're not in a place where we think is good for StarkNet, it is good enough for the time being. And indeed, in the next version, not 0.11, but 0.12, there are plans for much bigger improvements, right? So I don't know if you've seen, but earlier this week, maybe it was yesterday, time flies by, but we released, or we open sourced the sequencer, right? So in 0.12, basically the module that we've open sourced yesterday will be integrated into StarkNet. This is for a different community call for builders and delegators. But basically this integration will combine together 3 very important components, which I hope will give a major improvement to the performance. So one is the actual transaction execution that was released yesterday. 2 is basically the underlying state manager, or the full node that StarkNet sequencer will use will be replaced with a much more performant one, and this is Papyrus, which we released earlier this month. And lastly, also the Cairo execution will be replaced with the Cairo RS project by Lambda class that is already live and working in few of the development tools for a couple of weeks now. Okay, so this is performance.
Hey,
Now,
Tom,
yeah.
can I interrupt you a second? There is a question in the chat from Nicola about timeline. Nicola, do you want to open your mic?
Yeah, sure. No, it was just too much. I mean, what we are being said here is a bit more detailed than what we had on the other call. So on the other call, I heard, I think, 0.11 on testnet for mid-February and regenesis 3 or 4 months later. So that was just to see if you have the same perspective on that.
Yes. So I'll get to regenesis in 2 bullet points, and then I will answer that. But so just one second.
Okay, perfect. Sorry, I thought it was about timelines, which we addressed just before, but let's wait.
We'll go back to them.
Thanks.
It's all about timelines. Anyway, so the second is to get as soon as possible a stable version of Cairo 0 that is feature compatible with Cairo. Cairo 1 that is feature compatible with Cairo 0. So as I've said, we released another version today, which gets us one step closer to it. And the existing milestone is to reach the feature parity with old Cairo. And now we get to do the regenesis, Nicola, to what you've asked. So as I've said, the transition period begins with StarkNet 0.11. Yes, we hoped it to be on testnet by mid-February. I think we'll only manage to have it by mid-February on integration, and then 1 or 2 weeks after that on Gerli. So it's around that time. And the transition period will end basically, and this is what we call the regenesis, when the ecosystem will finish with the migration, which I really hope it to be 3 to 4 months, but I don't want to give hard timeline where we haven't actually started with this process. So if in 3 months we'll see that no progress were made, or in 3 months we'll see that everyone already did the migration, then we can get the decision there. But yes, I suspect it will be between 3 to 4 or 5 months, or this is what I hope.
I have a question regarding regenesis. Is regenesis, what is regenesis? Like, is it when Cairo 0 code becomes deprecated, or are there any other actions like, I don't know, block numbers going back to 0, something like that?
Okay, so you're asking what will happen here at the regenesis, right?
Exactly.
Yes. So the first thing that will for sure happen is that Cairo 0 contract will no longer be executable, right? So if a transaction will try to call a function in a Cairo 0 class contract, right? So they always will fail the transaction, and basically the sequencer will still be able to get paid for it, but we won't do execution on Cairo 0 contracts. So this is one thing. What we also want to do is to remove the old blocks of StarkNet for many good reasons. And there is a subtle question on how we not break, backward compatibility with events or transactions data or stuff like that. So we still need to find or to come up together with the best solution here, but those are the two motivations or things we want to do in the regenesis.
Thank you. And then in the chat, Julien asked, will 0.12 come before regenesis or after? So I'm guessing you mean before the end of regenesis, and Ariel answered before. So yeah, there will be various StarkNet versions before the end of regenesis. Is that accurate?
Yes. So
hopefully not too
0.12
much.
is already in the works in parallel. And it's actually making very good progress. So I hope it won't be long time after 0.11 that we'll see 0.12, right? Because it's actually, it's working on the Rust sequencer and working on integration with Python, but it's almost completely orthogonal to what we're trying to achieve with 0.11. Okay, so this is the context. If you have more questions around that, I'll be happy to answer. If not, I will hand it to Ariel to do a deep dive into 0.11 to understand how it will achieve StarkNet compatibility with Cairo 1, or what needs to change or adapted in StarkNet in order to be able to declare, deploy, and run Cairo 1 contracts. Okay, great.
I have one question about the planned repo structure. So,
yes.
So if you can go back to the previous slide. So right now, Cairo is both the name of, it's like one repo where both Cairo, the language, and StarkNet, the system, live. So can you talk a little bit about what's planned for the repo structure throughout the transition period?
Yes, I wouldn't couple it directly to the transition period, but generally until I think the Cairo RS, the Cairo VM in Rust was the first external repo to Cairo Lang that had a component of StarkNet that was part of the main infrastructure that the developers used. But in general, the aim for us is to at some point deprecate the existing Cairo Lang repository and to have each of the, I think, 5 components that currently lives under the same repo being independent repo that is developed in a public open source repo, right? So the sequencer, which parts of it are now lives in Cairo Lang, is already starting to live in its own repo. Same for the Cairo VM. The compiler is already now in a different repo, right? The Cairo 1 lives in a different repo. We have the StarkNet OS and StarkNet L1 contract, so they need to be moved also to an open public repo. And the last one, maybe Ariel, I remember we said 5, but maybe
we had contracts, we had the sequencer, we had the VM.
Compiler.
Yes.
And the CLI, right? Currently, the CLI also lives in the same repo, and there's no reason for it to be there. Does that answer the question?
Yes, yeah. And another question, you kind of touched on it before, but I think that it's important to make it very straightforward. So when is going to be the date where people are going to be able to start re-implementing their apps in Cairo 1? And how much time would they have to do it?
Okay, so being able to deploy and run contracts on StarkNet is together with 0.11. The features that you specifically need for your specific contract depends on what exists there. So for example, yesterday I talked with Marto from OpenZeppelin, and hopefully with the release today, they will already be able to start looking into their ERC20 contracts and start migrating them, right? So, but once we reach here, and again, I hope that we'll reach here actually quite close to 0.11, because 0.11 has been a bit delayed. So once we reach here, there will not be a contract that you can't migrate to Cairo 1. So I encourage basically every developer to, once we have even today, but specifically once we have 0.11, to start looking at, I think most of the code that exists today will already be migratable. And then how much time we have, so this relates to what Nicola asked. So basically the transition period until the regenesis is, we have a goal, but we won't do it when we see that, parts of the ecosystem haven't migrated. So I think we should aim to something like 4 months, but I think we should also, let the builders and the developers start doing it and seeing if our estimations are correct or not. Okay, any more questions?
Where can we find the list of things that are missing, the feature parity list for Cairo 1?
In the Cairo 1 repo.
Okay.
But I actually need to update it, so do it only in the evening.
Okay, thank you.
Okay. Ariel, go ahead.
Okay, so let me just share my screen as well.
And actually, sorry, in the meantime, another question. So
Yes.
where is a good place for people to discuss Cairo 1 issues?
Great question. So I think that, for small questions or, beginner questions or stuff like that, we open the Cairo 1 Discord channel, and I think this will be the best place. If there are some, either bugs or major feedback or, requested feature, then the GitHub either issues or discussion is the good place for that kind of discussions. But for immediate support, then the Discord channel is the best place. Both Henri and his team will, as the time goes by, will be there more and more. And currently the compiler team also monitors it and answer questions. So this is a good place to start. And hopefully soon builders will be able to answer one another. Okay.
Okay, just
Marco,
before I start.
I missed the last part. Is the latest Cairo release out today? Is there in 256 support? Yes and yes.
You can see it with your own eyes.
Okay. Thank you.
Okay. So I'll start going over the details of the changes expected in 0.11 and the exact motivation for those changes. This page is part of the StarkNet docs. So all you need to do to dive into this list in more details is go to the StarkNet versions section and check out the upcoming StarkNet versions page. And feel free to stop me with questions anytime. Okay, so like Tom said, the big addition with StarkNet 0.11 is the introduction of Cairo 1 into StarkNet. So far, it existed separately, but in 0.11, you will be able to start declaring classes that were written in Cairo 1 and deploying contracts, having those classes, and actually running Cairo 1 code as part of StarkNet. Okay, so there's actually a lot going on behind the scenes in regards to Cairo 1.0. It is more than a more convenient syntax and richer language for writing smart contracts, but it is actually a crucial element for having DOS protection in StarkNet. Okay, so essentially the issue is that now not all transactions can be proven. If you have, for example, an assert instruction in your contract and a specific transaction hit at an assert 1 equals 2 instruction, this transaction cannot be added to a proof. We cannot say that this transaction failed provably, which means we cannot provably charge fee. We cannot say, okay, we executed this transaction for 100 steps, we're eligible to take fees, sequencer is eligible to take fees, 100 step worth of fees. So this is not something that can be done today. And this is why we introduced Sierra, which is an intermediate representation between Cairo 1.0 and Cairo assembly. So right now, whenever a user writes in Cairo 0, this compiles to Cairo assembly, and this is what is sent to the StarkNet sequencer. From StarkNet 0.11, while this Cairo 0 still continues to operate as before, and you can continue to work with them until the regenesis. But for Cairo 1, once a user writes Cairo 1, he will then compile it to this intermediate representation, which we call Sierra, safe intermediate representation. This is what is going to send to the StarkNet sequencer. So the actual class structure is going to change. It will now consist of Sierra instructions. And the sequencer will compile this Sierra to Cairo assembly. And the very important property that we want to achieve here is that Cairo assembly generated from Sierra can always be proven. The compiler from Sierra to Cairo assembly does not generate not nice Cairo assembly that sometimes cannot be proven. So the canonical example that I like to hold in my mind in this aspect is instead of asserts, do ifs. So the Sierra 2000 compiler won't put asserts for you, but he will use if-else instead. This is a vast oversimplification, but I think it's a very useful example into understanding how this compiler will behave. Okay, so that's a first significant change, that now instead of sending Cairo assembly to the StarkNet sequencer, Sierra will be sent. And by changing this structure, this means that we're going to need a new declare transaction, which is what the declare v2 transaction is all about. Sending a different type of contract classes who consist of Sierra instructions rather than Cairo assembly. There is much more to say about this, and we'll dive into what declare v2 means, but any high-level questions about the purpose of Sierra in our in this effort? Okay. Then I'll continue to discuss declare v2. You see all the regular fields from the standard declare transaction, version, max3, signature, nonce, sender address, which is the address of the account contract sending the transaction. I haven't detailed here the specifics of the new class structure, but
yeah.
Yes.
Maybe before diving into the declare, go over all the changes that entails, or?
Okay, so I'll briefly list them. In addition to this new declare transaction, we have a change in the way the state commitment is computed. We'll get to that later. There are some changes in the on-chain data sent to L1. So right now, the state diffs between each block are sent to L1 to guarantee data availability. So the specific format of those state diffs will slightly change. We will introduce a new system call called replace class. This system call will allow taking your Cairo 0 contract, which already has a rich state in it, and allow you to replace its underlying class while keeping the address and storage. So this is how you'll be able to maintain significant state, especially on mainnet, when we move towards regenesis. The replace class is crucial for that purpose. And there are a bunch of API changes, both on the StarkNet side, on the feeder gateway, and on the full node JSON RPC that are related to mostly to the introduction of the new class structure and the Sierra object, but those are detailed under the API changes section.
Ariel, we have a question for the replace class Ash. Do you mind if we answer it now?
Yes.
Yes, you mind, or no, you don't mind?
No, I don't mind, and I just saw the question. So I'll repeat it. Can I use the replace class multiple times? So the answer is yes, we don't limit it. And in fact, this can be the de facto new way to implement the proxy pattern. Obviously, this isn't mandatory, but while we thought of this mechanism for the purpose of maintaining your address and storage towards regenesis, we realized internally that it can also be used for regular upgrade. And it can be a nicer mechanism than what we're used to with the proxy pattern. And it's all a result of the separation between contract and classes that we have on StarkNet.
It's actually quite interesting, because I think initially when we talked about this syscall, we said, oh, it's going to be available just for regenesis. But now we're thinking, wait, maybe this is useful. It's kind of native proxy. It's one more example of things where we figure out things are useful after seeing how things goes on Ethereum. Darlington in the chat is saying, wait, but for upgradable contracts, you only need it for the proxy. And it is true, you can update your proxy with it, but with this syscall, you can have a new kind of proxy. You can implement proxies differently. And I'm sure Martin here will have a lot of ideas on how you can implement this. Martin is saying Rootstock had an idea of having a native upgrade syscall. I'd be interested in seeing how this panned out.
Yes,
but you can basically, instead of deploying a proxy and having your implementation separately, you could basically inherit proxy functions or import proxy functions inside your smart contracts, for example.
Yes. So actually, we will have to decide as a community if we want to keep. Originally, we thought about it as a syscall only for the regenesis and to remove it from the OS afterwards. But we might want to consider to keep it, and this is clearly open for discussion.
Interesting. Martin is saying, I think there wouldn't be a proxy at all. Okay. So this will be an interesting discussion for a future community call, maybe. But okay, I think we answered the question. Thanks, Ariel. Please go ahead.
I agree. Definitely, whether or not do we want to keep replace class is an interesting discussion, and how exactly will a proxy pattern which utilizes the replace class will look like, because we need to have a concrete design for properly discussing this. Okay, so these are the high-level changes. I think the biggest change is the new declare transaction. So I'll try to go over it briefly, the important parts at least. So we already discussed the new class structure, which is now Sierra instructions. But you will notice here another field that doesn't exist in the current v1 declare transaction, which is the compiled class hash. So what is it? This compiled class hash is the hash of the Cairo assembly, which results from compilation of the contract class, now the Sierra object, to Cairo assembly. So the user wrote Cairo 1, compiled it to Sierra, sent this to the sequencer, but he will also compile this result again to generate Cairo assembly, add the resulting hash to the transaction, and sign on this data as part of the declare transaction hash. Why this is important and why did we add this field to the transaction? So the long-term plan for Sierra is to have the compilation from Sierra to Cairo assembly as part of the proof. So the way to guarantee that all contracts in the system are nice, that no one somehow managed to inject a malicious contract to StarkNet that allows DOSing the sequencer, the way to prevent this is to have every declared class provably compile from Sierra to Cairo assembly. So because you know that the compiler is audited and satisfies the desirable properties, and the proof will tell you that the deployed contract, its class is indeed generated from this nice compiler. But this is not yet the case today. Today, this compilation happens on the sequencer side and is not proven. So the user needs a way to couple the code that will actually be proven to what he's sending. So if I'm sending this, and this is hopefully what's defining the semantics that I wanted, for example, ERC20, here I have my transfer logic, my allowance logic, and everything I wanted. But what gets proven on every block is actually Cairo assembly execution, because that's what we know how to prove. Whenever a proof is involved, we're talking about Cairo assembly execution. So the sequencer will actually prove stuff about this. But if the user doesn't ratify and says, okay, that's actually the Cairo assembly that I mean for you to execute, then there's effectively trust on the sequencer. So in order to have this very important coupling, in the meantime, while compilation is not part of the OS and is not proven, we needed this extra new field. And that's maybe the biggest change in the declare v2 transaction. I saw a bunch of questions on chat.
Yep, basically,
most
but
of
people
them.
answered it. They were answered, but let's do it also for people on YouTube. Is declare v2 for Cairo 1 declaration only? And Tom said, yes, it's only for
Yes.
Cairo 1 contract. I got an extra question from what you explained, Ariel. Can we expect one day that the ABI will be proven also?
That's a good question. Since we don't have a nice encoding in mind for ABIs, and it is effectively JSON, we don't think that we'll be able in the proven compiler, which will be written in Cairo. The plan is to actually write the Sierra to Cairo assembly compiler in Cairo, and that's how we're going to prove it. So we don't imagine this compiler to deal with the JSON serialization and that sort of stuff. So the way to overcome this is to do something similar to what we do today, that the class, the contract class will contain inside it the ABI, and the ABI will be part of the class hash. So you can say nonsense in this ABI, but it will be coupled to the class hash. It will be a way for the person declaring to couple an ABI to this class hash. And if he hopes others to use it, you will probably want to put an ABI that makes sense there, one that is consistent with the actual compilation.
All right, thank you.
Okay, so that's declare v2. A few words on the transaction flow. So the sequencer gets this transaction. What he does is compiling or first running validate declare, just like today, to make sure this declaration is valid, this signature is valid. If the transaction turned out to be valid, properly signed, then he will compile this class and make sure the resulting compiled class hash matches the one given by the user. If this is not the case, then the sequencer is eligible to charge fee for this transaction, because this is effectively treated as a DOS attempt. You tried to cause the sequencer to basically run a bunch of compilations which don't match what you said they are supposed to match. So putting nonsense in this compiled class hash, in addition to not providing guarantees that the actual proven code corresponds to what you sent, it will also mean that fee can be charged for this compilation attempt. Okay, so the high-level flow is the sequencer gets it, run validates declare, compiles the class, and make sure that it matches the one provided by the user. Okay, so with that, we're past the declare v2, and maybe a final word on Sierra is that the way to think about it is that now the class, the StarkNet class semantics, is reflected in the Sierra code. So when you're calling a contract or deploying a new contract, which means when you're using the library call, system call, or the deploy system call, you're specifying the class hash. You're referring to this object, and you're never talking about the compiled class hash. The compiled class hash only exists for proving purposes, but the semantics is encoded in this object. So if I want to deploy a new instance of this class you just declared, I'm specifying the class hash, not the compiled class hash. Okay.
Yeah, because it's a bit different from what we have today, so it's good to make sure that it's clear. I can give another example on how this can be used. Maybe it will clear stuff, maybe it will make it more complicated. So what do you want me to give it?
Go for it.
Schrodinger's explanation.
What? Apologies?
No, please do it.
Okay, so can you go back to the declare transaction?
Yes.
So as Ariel said, the contract class, which is basically a Sierra code, actually defines exactly the semantics of the class, right? And then how we can use it, this notion of this separation notion, we can have it be compiled to Cairo if we want to prove it, but we can have it be compiled to something which is more efficient to run on x86 if we want to only execute it in the sequencer, for example, right? So you can imagine a compiler from Sierra to LLVM, which is something that few teams in the ecosystem have started exploring to allow more efficient sequencing. And this, we can do it because we have the separation or this decoupling between what we actually need for proving and what actually defines the semantics of the class. So I hope it helped.
Yeah, I'll say maybe a few more words because this is a delicate point. So Cairo is only needed for proving. If we didn't want to prove things, we could have just executed Rust. So Cairo was invented and developed for the sole purpose of being able to prove computation. The sequencer was producing blocks, and actually all the developer tools who are running StarkNet contracts don't really care about proving, or the sequencer can be decoupled from proving. It can be someone else's responsibility. So if the semantics are encoded in this object, you can treat it directly. However, in the coming months, at least, there is no Sierra to LLVM execution. So the way to execute your contract would be to compile it to Cairo assembly and use Cairo VM implementations to execute it. But in the future, you may not need this extra compilation step. Maybe I also added more confusion, but hopefully not. Okay. State commitment. Currently, the way the state commitment works is we have one global tree, similarly to Ethereum, where the leaves are essentially storage routes for each contract, which encode the storage of the contract itself. After 0.11, the StarkNet state commitment will consist of two trees. One corresponding to the contract state, exactly the same as the tree today, and the other corresponds to the classes which exist in the system. So we're going to construct a tree from the key value pairs, where the key is the class hash and the value is the compiled class hash. And this will be part of the state commitment. So every time you declare a Cairo 1 class with a declare v2 transaction, you're changing the state commitment by adding this pair to the classes tree and changing the eventual state commitment with now the hash of two different roots. So we have the global state tree, same as today, but we also have the classes root. So every declare affects this classes root. Okay, that's the state commitment. Why are classes needed in the state root? Why weren't they needed before? Very good question. Okay, where are they needed before? The answer is that the code itself was present before because the leaf of this tree also contained the class hash. And every time we executed a contract as part of the proof, we made sure that the class we're using corresponds to the class hash that appears inside this tree, that we're not inventing arbitrary code and running this instead of what you intended. But you are correct in that there was no coupling between declaration and the state previously. For example, up until now, if I only declared a class and didn't deploy a new instance of it, this information was not reflected in the state commitment. And this is effectively a mistake. You do not want this behavior. This can cause a bunch of confusions around the sequencer being familiar with a bunch of classes while a full node isn't. Having the classes well defined in the commitment solves every ambiguity. Everyone knows exactly what classes are part of the StarkNet state. And with Cairo 1 classes, we're starting afresh. So old classes that are eventually not going to be accessible after the regenesis, they are still not going to be part of the commitment. But new classes, new Cairo 1 classes that are added by declare v2 from day one, they are going to be a part of the commitment. Does this answer the question? Okay, good. Okay, replace class. So maybe the other heavy change in this version, the system call that allows you to replace your class. So I think the easiest way to see it is by an example. So this is the Cairo 0 contract. I have two external functions, swap and get price. I have no idea what this does, but get price is called inside swap 3 times, twice in an inline manner, and once via the call contract system call. And as you can see, between the first and second get price call, I'm using the replace class system call. So the way this will work when I call swap is that here get price from the existing class will be used, no surprises. Here I'm calling get replace class, and assuming this class was previously declared, I'm transitioning my class. If this class was not previously declared, then I'm failing at this point. Let's assume it was. This get price call will still use the old class implementation because we are concluding the context that we were executing so far. Calling replace class doesn't magically take you away from what you're currently executing. We thought this would be a more reasonable behavior for the execution flow. But if you will call your contract via the system call and not in an inline manner, then the new implementation will be called. So in this example, here and here we're using the old class, but here we're using the new class, and this will work assuming the new class also has a get price method. So that's the flow of the replace class. I saw there's a bunch of questions there. I'm not sure if they're about replacement or about Sierra.
Questions about the need for the state commitment for adding the class to the state, and what changed with Cairo 1 that made us do this change and not do it before.
Okay. Did we answer it?
I think, I don't know. I wrote some sentences. I hope they answer.
Okay, if they didn't, then let us know. Okay, so I'm continuing with the replace class. So this is how it's going to work. And the proposed mechanism by which you're going to replace your class is the following. And note this only works for upgradable contracts. So suppose your contract is upgradable, then on the implementation side, you have no problems. Once you re-implemented your logic in Cairo 1, you declared the class and you sent a regular declare transaction. This is not a problem. But how you are replacing the class of the proxy itself, which is a Cairo 0 class, and it is the one with the interesting address and the interesting storage. So the proposed flow consists of the following steps. First step, you work on your Cairo 1 implementation and the proxy. Okay, so now you have the Cairo 1 proxy class ready. Now you can upgrade the implementation to a one which has the replace class system call in it. Okay, so now you've upgraded the implementation. The proxy is still a Cairo 0 class, but the implementation has replace class logic inside it. Now you're calling this logic that you recently added, which makes use of the replace class system call. So this is a transaction to the proxy, and that's it. Now your class is replaced, and you're ready for the regenesis. And I see a question on get price. Does not use the new class hash yet. Okay, so the reason we're not.
Ariel, repeat the question, please.
Yes, sorry. So the question is, why exactly this uses the old implementation while this uses the new implementation? Okay, so there are two parts to this answer. One, the trivial one is that the current way system calls work, it's much more natural to have other system calls use the new class. So if I called this system call before this one, then the later system call will know about the changes from the previous system call. But the other reason, which I think, I don't know, at least to me makes more sense, is that I don't want to break the current flow. Eventually, this call is effectively a jump. I'm doing stuff inside my currently running code, and I don't want to overload this. I don't want to hurt the current execution stack. While system calls, they live on a different flow. So here I'm allowing you to conclude the current execution, but later system calls will know about the changes from older system calls. I hope this helps. Yes. Okay, so there was a question about the replacement mechanism. After I follow these steps, does the upgrade to the proxy class happen with the replace class call that lies on the implementation class? Then yes, that's exactly how it happens. The implementation class has the replace class logic, and this affects the class of the proxy contract who calls it. And yes, you can also later remove this upgradability feature by replacing to a class that doesn't have it. Actually, I need to think a bit more about it. If you want that, make sure that your current proxy contract no longer has upgradability mechanisms. I think this requires taking this offline and actually writing down the contracts. But thinking about it for very briefly, I think that the answer is yes, that it can be done. And I see there are a bunch of more questions, but we're also running out of time. So, Henry, how should we approach this?
I'm sorry, can you repeat the question?
We have a bunch of more questions, but we're running out of time.
I have time. I don't mind if we take
Okay.
a bit more time.
So I may have to drop, and Tom will
because
bravely
you're busy. You
my
have some
place.
place to go. I see. I see.
I'm here.
But let's try to cover the questions so far. How to migrate the proxy Cairo 1? It's not clear that replace class upgradability cannot use proxies. You'll be upgrading the proxy and never the implementation, so it doesn't make any sense to have a separate implementation. I'm not sure I understand. Do you maybe want to ask this via mic?
Hey there, can you hear me?
Yes.
Yes.
It wasn't a question actually, sorry, it was a comment that since the replace class being called from the proxy will be replacing the proxies class, then that's a new upgradability mechanism that it doesn't require any implementation. If you had an implementation contract, you would be always upgrading the proxy implementation, so you don't actually need an implementation contract. So what I'm saying is that this is an upgradability pattern without a proxy scheme. It's a single contract that upgrades itself, no proxies. It was just a comment, sorry, not a question.
Even today, but even today, I'm using the term proxy contract loosely, because even today, the mechanism in StarkNet uses one contract and two classes, the class of the proxy and the class of the implementation. There are no two contracts involved ever since we moved to the direction of separation between contracts and classes. Correct. So I don't think it's different in that sense. But yeah, if I made it sound like there are two contracts going on, then yes, that's not how it's going to look like.
It sounds like it's going to be one of those things in crypto where we designate something by a name that isn't accurate, and we're going to be calling this proxy pattern, when what you're saying, Martin, is that this is not a proxy, it's native replaceability or something. It's something else. It's not a proxy, but it achieves the same functionality, meaning being able to upgrade your code. Is that correct?
I agree, it is.
Yes,
let's
maybe
find a new name for
that. Maybe proxy now becomes not an ideal name, but I think that in the near future, what people will be looking for is, how do I implement proxy in StarkNet? So ZK proxy is a nice name. Maybe.
But it's not a proxy.
Yeah, it's also not ZK.
But it's a fancy name.
It has ZK in it.
Okay, I have to move to a different call now, so I will let Tom take over. We basically covered, I think, the heavy lifting of v0.11. What's remaining is the API changes that accompany what we've discussed so far. Yep.
Okay, thank you, Ariel.
Thank you.
Can you stop the screen share? I'll take over. Thank you. Let me see where it is. Yes. Okay. Can you see my screen? Okay, great.
Yes, sir.
I'm really excited. So just please take a look at the release notes of the last 3 weeks on the Cairo 1 repo. It's really nice thing to see. Okay, now back to our version. Okay, great. So we finished with the replace class syscall. Do you see, or do I need to increase it? Is this okay?
No, more, please. Bigger.
Okay, okay. How is that?
Now it's good.
Okay, so we finished with the replace class syscall. If there are more questions about it, then let's get back to it at the end. And as Ariel said, the on-chain data changes and the API changes and the JSON RPC changes are all basically to reflect those changes to how we treat class and compiled class and this duality. Okay. And also the on-chain data will now have specific a treatment to replaced contracts, right? So I can go into the details, but basically everything is written here. I don't think it's that important to go specifically into those details. Okay, the API changes. So again, we added the get compiled class, which basically returns the value under the class in the classes state. And the get class by hash now return two different objects, depending if it's a Cairo 1 contract, a Cairo 1 class or not. Same for a full contract. And in get state update, there are a few changes. So one, there is a explicit new field that mentions classes that have been replaced, right? So it's basically an address and the new class hash. And also to make it easier to populate the state, the class state, the declared contract is now split into all declared contracts, which basically contracts that use declare v1. Hopefully there won't be a lot, but I mean there will be at least few in order to utilize the replace class syscall. Yes, and small changes. Any other questions on those changes? I see there's a lot of discussion.
People saying they have to move. So, but aside from that, there were a few questions on YouTube, but I answered most of them. Some people asked to go over the upgradability flow for Cairo 1 with the replace class hash, but everything is declared in the docs, so I highly encourage you to go check it out. I've added the link in the video description. And then one interesting question, maybe people are asking, if we're starting to develop an application today, should we do it in Cairo 1 or Cairo 0 and upgrade later?
I know it's like the worst time to ask it, but yeah, I would tell you to start learning Cairo 1 and to start developing, I don't know, other parts of the applications, which are not the smart contracts per se, because really like a month from now, hopefully it will be just possible to write everything in Cairo 1. So maybe come to StarkWare sessions, you have a week there, then, you know, spend the time to learn Cairo 1, write the backend, the front end, and then at the beginning of March, just finish with the smart contracts and you can immediately deploy.
It's actually a good thing. Like I would encourage people to start working on the architecture of their application, like the business logic and maybe the front end, which won't change that much in the future. And then work on the smart contracts starting, like if you start in 2 or 3 weeks, you can get on to it directly with Cairo 1. And if there are features missing, by the time you'll need it, we'll have front run you and they'll be available. And we have Nicola asking, maybe this is a question for another community call, but he heard there was a migration from Pedersen Ashes to Poseidon in progress. Can we get an update on that? Is there any timeline? Because that might be an important change for constrained signers.
So yes, Nicola, thanks for the question. So actually it is not written here and we'll update it as soon as possible, but the state commitment, the new state with the classes and the new classes hash computation will transition to use Poseidon. So Poseidon is basically a Stark friendly hash function that was developed a few years ago in an effort to find like specifically hash functions that are efficient for Stark proving or in general for validity proofs. And it's something like 10x more efficient on the proving side and also 10x more efficient on the x86 side. So it is on both parameters better than the existing function Peterson. So we, in general, want to transition StarkNet to use Poseidon. Now, what we do now is that everything which is new, we edit with Poseidon, right? So as I've said, new classes hash will be computed with Poseidon, and implementations to Poseidon will be supplied in both in Cairo and in the crypto CPP. And there's also Pathfinder are already working on a Rust implementation, and also we already have an implemented JavaScript implementation, an efficient JavaScript implementation by Paul Miller. So it does exist. Apologies. With regards to the, for example, the transaction hash and the old state, so this will, I think we want to have it as part of the regenesis. Again, it's a discussion that needs to be made. How do we do this transition? Do we do it in some trusted way that can be verified off-chain? For example, just transition to use a new hash function and give the data and the script off-chain to be able to verify it? Or do we do it via a validity proof, right? Having a proof that says, take this state, compute the commitment with Peterson, compute the commitment with Poseidon, and see that you can do the transition. It's a very big proof, so we need to decide. I think this is mainly a community or ecosystem decision, what is good enough with respect to trust. So I hope this answered the question by Julian. Nikolai, if not, let me know. And we can also discuss it in great details next week in StarkWare sessions.
All right. So I think we covered most of what we wanted to cover today. Is that accurate?
I think it is.
Very nice. So, okay, let's wrap it up.
People are not here, but maybe if they will hear it afterwards, or for people who are here. So the purpose of this meeting was to go deep into 0.11 to allow the decision on the version to be made with more knowledge. So I would love to hear if this format helps, if it's good, if there are other ways you think we should do it. It was the first time, and I'm sure there are many ways we can improve.
And I also wanted to say that we encourage people to continue asking those questions, especially over Stack Overflow. We are, I mean, maybe it's like better for Henry to say it, but yeah, we have Stack Overflow, the community forum, Discord. We'd love to have people ask technical questions and questions about the architecture of StarkNet going forward.
Yeah,
we have those
absolutely.
discussions, not just in those community calls.
Absolutely. Get involved, ask questions whenever you need. And as Tom said, do let us know if this process makes you feel more comfortable with the upgrades coming in StarkNet and you feel like you're informed enough to vote on them, because ultimately that's the goal. It's for you to decide. So get informed. All right, so let's wrap it up. One final word. Gal, you have a nice background stating that next week is StarkWare session in Tel Aviv. Everything is on the program. It's going to be a nice conference. Gal, Tom, can we get a recommendation? What is the one thing people need to eat during their week in StarkWare sessions?
It's called Sabilabane.
Sabilabane?
Sabilabane, yes.
Okay, I have a colleague in Tel Aviv. I'll ask him where to get some.
Exactly. I think Gal does not agree with me. He has maybe a more fine taste.
What would it be, Gal? What's your recommendation?
I honestly have no idea what Tom just said. But you should know that some of the literally like 2 of the top 5 restaurants in Israel are 50 meters from the conference venue. I'm not going to say their names so that you'd have to work a little bit before all the spots are taking over there.
All right.
But yeah, some really good food around the conference venue in Tel Aviv.
Amazing. All right. So I hope we'll see a lot of people there. And thank you for attending our call today. Until next time.
Bye-bye.
Bye.